Hello everybody. Today we are going to talk about the periodic table and kind of introduce the different things that you will need to know about the periodic table and the things that you'll see on this. So most of you got this pink periodic table in class. If you didn't, that's okay. You can use any periodic table on the internet. They're all pretty much the same. They give you the same information. So it doesn't matter what periodic table you use as long as you just are using one. So I have a list of things that we're going to talk about here. And I'm going to start first with periods of the periodic table. So if you look on this particular one, the periods are listed here. So they go up and down on the list. But in reality, they go across. So period 1, this one, goes across this way. And there's only 2 elements in period 1. So hydrogen and helium are the only 2 elements in period 1. Period 2 has lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So period 2 goes across this way. Period 3, and then period 4, period 5, period 6, and then 7. So there's 7 periods total. But if you look at something interesting on the bottom of the periodic table, you can see that periods 6 and 7 sort of go from 56, 57 to 72. So the missing numbers between 57 and 72 are actually down here. So 58 through 71 are actually supposed to go in there. But to make the periodic table sort of compact and enough to fit on a piece of paper, these 2 columns of period 6 and period 7 are just placed down below so that you can basically fit it onto a piece of paper. If not, and sometimes I do this in classes, I show you what it would look like if it was all stretched out and actually put in place where those 2 go. So period 6 and 7 actually just continue down here. So period number goes down this way, but the periods go across. So period is the horizontal direction. Let's make a little note of that. And then the next thing is going to be groups. So the groups, if you look here, group number goes this way. So group 1 are the elements in this column here. Group 2 are the elements in this column here. Group 3, group 4, so it's all the way down. And then you can see that there are 18 different groups. So 1 through 18 for groups. The groups are really important because groups, we'll just do this, so they go down. And there's 1 through 18 groups, 1 through 7 periods. That's important to note. So the groups are important because what you see with a group is elements that all have the same characteristics. So in group 1 here, these are all called the alkali metals. The alkali metals all have similar chemical characteristics. And the reason why is because they all have 1 extra electron that they need to get rid of. So that's what group 1 all has in common. So within a group, elements behave in similar ways. Similar to group 2, which is the alkaline earth metals. Each of the elements in group 2 want to get rid of 2 electrons. So they all have the same basic chemical properties. The elements between 3 and 12, these are called the transition metals. They do have similar properties, but these are all pretty much similar to each other. As you move over to this side of the periodic table, I'm wondering if you know anything about group 18. So group 18 elements are the noble gases, and they're the noble gases because we call them inert gases or noble gases. And it's because they don't need to gain or lose any electrons. They're already stable. So they have a pretty good outer electron shell already. It's already full. So they don't need to mix with any other elements to become stable. Everything else on the periodic table usually needs to bond with another element to become stable. And we'll talk more about that later in the year. So group 18 elements all have the same characteristics. Group 17 elements are similar to group 1 elements. All group 17 elements need is to gain 1 electron. So group 1 needs to lose 1. Group 17 needs to gain 1. So they're all similar characteristics. So within a group, those elements all behave similarly. Now, across a period, those don't necessarily mean that they're similar elements. So across a period doesn't matter as much as down a group. So elements that are down a group would behave in similar chemical ways. All right, so next on my list here is element tiles. So take a look at the sample element tile that it gives you right here. So first you have the name, which the name is very important, of the element. You may obviously recognize some of these element names, but I guarantee by the end of this year, you will be very, very good at naming them all and finding them all. You'll never have to memorize them, but you might just happen to memorize some by accident because you're going to be looking at this so much. So you'll be surprised at how many elements you learn and remember the location of pretty quickly. So the name, the symbol is going to be whichever the symbol is. So notice that some elements have a singular letter for the symbol. And in that case, it's always going to be a capital letter. And then if the element has a second letter, it always is lowercase. So for example, iron, so Fe. Make sure that when you're writing or typing the element symbol that you use one capital letter. And if the element has a second letter, it has to be lowercase. So that's the way that we write elements. They're not like states where it's 2 capital letters. It's always going to be 1 capital, 1 lowercase. So the other information that the element tiles give you is the atomic number, which is the top one here, and the atomic mass, which is the bottom number that's usually always in a decimal form. It's in a decimal form because that is the average atomic mass. We'll talk more about isotopes later, but it's because it's an average of all of the different elements that exist for that particular type. So atomic number. Atomic number is one of the things that's on the element tile. Atomic number tells you a lot of things. So the atomic number, if you notice, the periodic table goes in order of increasing atomic number. So atomic number 1 is hydrogen. Atomic number 2 is helium. Atomic number 3 is lithium. And they'll go across and in order of increasing atomic number. Atomic number tells you a couple different things. So I want to see, make sure that you can write this down. So atomic number equals the number of electrons that any element has and the number of protons. So that is an important bit of information. So if you know the atomic number of an element, you also know how many electrons it has, and you also know how many protons it has. For example, carbon. Carbon is atomic number 6. That means carbon has 6 electrons, and it also has 6 protons. So that's an easy way to know these 3 things with just this one piece of information. Atomic mass. I actually just kind of already talked about that. So atomic mass is the number at the bottom. That is a decimal. You can round to the nearest whole number if you need to when we're talking about atomic mass. So like carbon 12.011, you could round that to 12, or boron, which is 10.8. You would round that up to 11 if you want. It's okay to round those to the nearest whole number. Now the element categories and metals versus nonmetals. So this is a pretty big concept that we want to make sure that everybody addresses. So the first category is metals versus nonmetals. So if you look here, there is a big sort of bold line going across the periodic table. And if you want to make that line even stand out even more, you could outline it with a black marker just so that it sticks out a little bit more. So this is what we call the zigzag line. And the zigzag line is kind of the dividing point in the periodic table between metals and non-metals. So everything on this side of the zigzag line is a metal. And everything on this side of the zigzag line is a non-metal. Now, you can tell that most elements on the periodic table are all metals. So everything on this side of the zigzag line is a metal, and the only non-metals are just in this small upper corner here. So there's way more metals than there are non-metals on the periodic table. Now, there are some elements that touch the zigzag line that are actually called semi-metals or metalloids. And those are elements that have properties of both metals and nonmetals. And those are specific ones that you will see on your coloring page. But I'm going to just give them a little dot here. So boron is one. This is a little tricky because aluminum is actually not. Aluminum is a regular metal. Silicon is one. Germanium is one. Arsenic is one. Antimony, tellurium, and polonium. Yeah, maybe not AT either. So these are the semi-metals, and you can note them on your periodic table so that you make sure that you know which ones those ones are. Also make sure that you know that it's not aluminum. So basically everything that touches the zigzag line is a semi-metal except for aluminum. Aluminum is a regular metal. So these are all metals down this way, and the non-metals are up here. So that is a basic overview of the periodic table. What you are going to do today is if you have a paper colored periodic table, you're going to color in those categories of each of the different types of metals. And then the non-metals. Oh, you know what? And I forgot to mention one little thing here. Hydrogen. Hydrogen is a very, very strange element. Sometimes it can act like a metal. Sometimes it can act like a non-metal. But for most purposes, it is a non-metal. So hydrogen is the only one on this side that is a non-metal that goes with this category up here. So take a look at the colored periodic table. If you're in class, you're going to color that. If you are remote, you can print one off and color it, or you can just use the one that I used online. Let me know if you have any questions, anybody, and hope you liked this video.